Well, hello and good afternoon to the systems engineering community. Welcome to another of our seminars. In today's session, we have a very special guest who is representing the Great Learning Company and its data science project of the University of Texas at Austin. He's also a professor of the University of Berkeley, California. We feel very honored he took the time for being here with us. And having said that, I'm going to give the floor to Luis to give the proper introduction of our today's lecturer, Vinicio De Sola. Please go ahead.
Vinicio De Sola holds a Master of Financial Engineering from University of California, Berkeley. Have a Master Business Administration, MBA, from University of Illinois, Urbana-Champaign, and a Master of Information and Data Science from University of California, Berkeley. He is a great learning mentor and an industry expert, having worked as a data scientist at financial firms as a consultant. Additionally, he is a university lecturer at the University of California, Berkeley. Thanks and welcome, Vinicio.
Excelente. Thank you very much. So yes, my name is Vinicio. Very glad to be here. So today I'm going to do a quick seminar in terms of what data science is. A few things. You can, again, whenever you have questions, it's fine if you can put it in Spanish. También hablo español, so no hay ningún problema. Soy originalmente de Venezuela, aunque llevo viviendo en Estados Unidos por los últimos 8 años. So my main objective today is to give you a little bit of an introduction of what data science is, what data analytics is, how can you become a data scientist or a data analyst, what are the different elements of the path that you need to take, and hopefully also explain what Great Learning does and provides for you to kind of like go through that path. And again, any questions you can post it and we'll be happy to answer them by the end. Okay. So a little bit of the agenda of today, I want to highlight 3 of the most important elements in your data career. I want to call it data instead of data science, data analyst, data engineering. These are the 3 main components. You can have data analyst, you can be a data scientist, or you can be a data engineering. Now, don't get me wrong. There's a lot of overlap between those 3, but it's very important for us to understand the differences because at any point, if you want to focus or follow one of the paths together, you have to know what are the differences so you can know exactly where to focus in your studies, where to focus in your projects, where to focus in everything regarding that. Then, like I said, follow up with how to build a career in data, in particularly how are we able to create those expertise. Right? You'll see that data science is a very interesting field because it's really the intersection of 3 main elements. And I want to make sure that you understand what are those. Then, of course, an importance in the job market. You probably have heard this term, data science, data science, data science. And it's been exploding over the past 5 years. And I'm going to kind of like a little bit of explain where in particular it has exploded. And at the end, explain a little bit about what this program is. Like I said, I've been mentoring this program for the past year. And I think it's a fantastic place to, get your foot in the door if you want to start building your data science career. So what are the 3 main areas? Data analyst, data science, data engineer. So let's start with data analyst. What is a data analyst? Well, a lot of companies nowadays are shifting from gut feeling, making the decisión from the heart. This traditional, like, tengo un presentimiento. And instead of doing that, we're making data-driven decisions. Okay, we're going to make decisions based on the data. So a data analyst needs to solve problems by getting insights of the data. That's it. Very simple. So you're going to have your data. And the data is, what is the data? The data is a summary of the history of the company. It's a summary of the behavior of the consumers. It's a summary of how the market is evolving. Again, depending on your field and on your industry, data can mean multiple things. But at the end, what the data analyst wants to get is insights. Can I learn? Can I predict? Can I really understand the behavior of the past And can I use that prediction, or can I use those insights to make decisions about the future? Okay, so a data analyst is always solving problems. Now, the next level will be data science. So again, a data scientist can be a data analyst, and typically a lot of projects start from a data analysis perspective, which is just exploring what is the data, what exactly am I trying to solve, what is the right question. Okay, and I'm going to ask that a lot. It's very important that the data as data is not enough. You need to understand, am I asking the right questions? And now that you know all of that, you need to predict. Okay, this is where science enters the picture. We're going to try to use mathematical and statistical models to solve problems. So you probably have heard machine learning. The name seems so fancy, no? The machine is learning. Well, in reality, machine learning is just a fancy word to say optimization. It's just learning to optimize problems based on data. Okay, simple as that. So if you come from engineering and you know optimization as a whole, you already have all that you need for starting a machine learning career. Okay, but it's not only optimization. You also need to understand the statistical models to solve problems. So this is where you have hypothesis testing. This is where you have confidence intervals, knowing about distributions, knowing about standardization and so forth. So at the end, the data scientist will not only get the insight from the data, but it will try to learn. That's the word, learn. That's why it's called machine learning. You try to learn past behaviors and use history to predict the future. So it's creating actionable models. Now, it's called science because it uses the scientific methods. You're always creating hypotheses. You're always testing to see if your model is behaving correctly. That's, in fact, whenever you're doing data science, you're dividing your data into two. You have trained data, which is the data that you use for training your models to learn. But then you need to take that model and test it out in data that you have not seen. What happens when the model is in the wild? What happens when the model is alone? Is the model correctly predicting the future? So that's why it's called data science. It's all about using the scientific method for it. And finally, I don't want to left out data engineering. Data engineering is a very different element. It's not as clear as data analyst or data science, but it's to get the data ready. It's all about data pipelines. To be honest, it's still a very important element of the data process. Nowadays, it also has been exploding so far. So, to be a good data scientist, you also have to have some data engineering on your back pocket. Now, how can we build a career in data? How can we really go out of our way to start building, this acumen? What do I need? Well, there are really 4 components of your data science career. The 4 components are business knowledge. A data scientist, I always tell this to my students, and I apply every day in my job. It's all about telling stories. You're a storyteller, okay? So as long as you know what you're telling, you can be a successful data scientist. It's all about storytelling. But if you want to tell a story, you need to have experience in the business that you're working on. So you need to have, hey, you're working on the financial sector. You need to have experience in the financial sector. You have to work in supply chain, experience in supply chains. Do you want to work in tech, experience in tech, pharma, experience in pharma? But then the other 3 areas, which are the ones that you can build in a kind of like in a student's perspective, are stat knowledge, math knowledge, and coding knowledge. You need to know how to code. You need how to express mathematical models through equations, and you need to understand how to apply probability and statistics to your problems. Okay. In terms of coding, nowadays, Python is the king. But again, one of the things about data science is that it's very fluid. It's not dependent on Python, although Python has the biggest libraries of data science. But there are multiple languages out there that are trying to compete with Python. And if you start building big data pipelines, then you need to combine Python with Spark. So again, coding is more about understanding how to apply algorithms. And it's agnostic of the language that you want to learn. Now, what are the main paths? Well, you can do machine learning. Like I said, these are the models that I described. AI, artificial intelligence, is also an area of machine learning. You can focus on visualization, simple as creating beautiful dashboard for your executive committee to make decisions, or you can just focus on research. Especially the research component is mostly science. Like, hey, and this is why your big tech companies, your Google, your Meta, Uber, they have research facilities where they're just solving problems, maybe not related to their main business, but from that research, something can come up from their main business. Now, what is the importance of data analysis and data science? So several industries are shifting to be fully data-driven. And in fact, I asked these questions to my students. Do you think Tesla is really a car company? If you compare Tesla capitalization, market capitalization, against all the other automakers, Tesla is almost as big as the sum of all the other markets, of all the other car makers. Why? If they don't produce that amount of cars? Well, because Tesla is not only building cars. Tesla is building a very interesting data project. Okay, their self-driving car is a fantastic project of how to use data, because they're using their surroundings and making decisions in real time using the data of different sensors to have that self-driving car. So the real capitalization of Tesla is not their market, it's not their cars, it's their data part. Many industries are being disrupted by data science, and they're heavily leaning toward data. Finance, again, that's the industry that I've been working for the last 8 years, but you have retail, e-commerce, pharma. Pharma has been relying heavily into data science. Your Pfizer, your Moderna, all of these are focusing exclusively on how to learn a lot from data science. So for example, an interesting project in pharma is using AI to identify correct markers on DNA that help us build better vaccines, to give you an idea. And also entertainment. Okay, we know that there are multiple streaming services. They have a lot of data from the users, and you need to keep the user engaged. How do you keep your user engaged? How do you keep your user, scrolling, watching, interacting with your service? It's another important area of data science. Again, the world is going digital. Every company collects data from everything, from what we do, from what we see, from what we click, where we stay, and you can really leverage that data that you're getting from your clients, that data that you're getting from your consumers to drive business value. Now, let's put great learning into this. What is great learning going to, what is great learning doing to be able to create this environment? So the idea of great learning is that it will enable career success through learning, to transformational learning experience. So it's a very interesting component where instead of focusing on just a class, you have a full environment where you try to go over different areas, where you have experience and exposure with real data scientists, but you also have a lot of material through a learning system where you can go into your own pace. You have real-time projects and so forth. So you can establish a track record of meaningful outcomes, meaning you can create your own portfolio. It's very rigorous learning model where you have a hands-on interactive learning. Like I said, it's not only learning through, like I said, a massive online course, which are quite prevalent, but you also have this live experience where you really go and sit down through a Zoom call or in a real place with a real instructor that is going to go a couple of hours through the material with real examples. Okay, hands-on learning. And at the end, you also have a full-fledged system of support that allows you to really understand how the technology works. So this all kind of go into this program, the SBA program that the University of Texas provides. This provides a very concise path to learn to use data. Okay, so again, we're taking beginners and we're molding you to have knowledge on everything that we have covered before. So you're going to start with learning how to use Python properly. Like I said, Python right now is king. But again, once you learn one programming language, you probably are able to learn any other. Then we're going to shift into business statistics. Like, hey, statistics and probabilities are a very complex topic, and a lot of engineers knows that. But you should understand how can we use statistics to make decisions. So it's mostly about either accept or reject the different hypotheses that we have. And then we go into machine learning, covering very interesting concepts like regression and classification, and decision trees, which are, of course, part of regression and classification. And even we take some time into unsupervised learning. Unsupervised learning is the way of learning the data from the sake of the data without having to predict anything. So these are great to learn, for example, what the consumer wants. It's not about predicting the consumer, it's about learning about the consumer. So it's an excellent mix of asynchronous material, mentor sessions, and real life projects to create your portfolio. So here you can see kind of like how it works. It's fully online. You have live mentorship session with industry experts. You have a dedicated program manager. Again, that is not your mentor. So you have your mentor to get the experience of real practitioners, where you go through real examples of the material that you learn during the week, but you also have a program manager that can help you with any elements from it. You have video lectures, you have quizzes, you have practical exercise, you have a lot of reading, and you have projects. These are very important. When you have a project, you have to go through it. You have to go through the gauntlet of the project, and then at the end, you discuss one solutions with your mentor. And it's quite short, to be honest, to be, being a lecturer of data science. There are multiple ways to start this, but if it's the first time, if you want to just start the career, this is a great kind of like starting position to aprenderlo, because it's only lasts 6 months. Now, this is everything that I want to cover. A few things that is in the appendix, and again, we're gonna share these slides at any point. This is what I meant when I said that data science is this amalgamation of 3 elements. Data science is domain knowledge, computer technology, so coding, and math and statistics, okay? It's literally knowing those 3. Data science is in the middle. You cannot have one without the other. You have to have very good coding skills. You have to know the math. You have to learn the stats. And again, business knowledge is as important as the other 2, because remember, you're telling a story. And if you need to tell a story, you need to be able to tell it properly. Okay. And finally, the last thing that I want to cover here is we have covered data science. Great. But we know that there are multiple things like, hey, what is artificial intelligence? What is machine learning? What is deep learning? So artificial intelligence is kind of like a bigger area where it's simple having a machine do things that human does. So every time that you're, for example, asking for a credit and you get the response immediately, that's artificial intelligence. It has program, it's an algorithm that knows that. But an area of artificial intelligence is machine learning, where instead of just making decisions using, let's say, a if-else statement, you make decisions based on data. And finally, inside machine learning, there's deep learning, which is really the boom nowadays. What is considered AI nowadays is typically deep learning, which are these very complex neural networks algorithms that are based on trying to understand how we speak, how we see, and how we think. Okay, so your Alexa, your Google, your Siri, and any of these elements, for example, whenever you're tagging a picture and it knows who you are before you tag it, that's deep learning, learning about how we think. So hopefully, this allows you to understand every area of data science. Again, this is an introduction. And I think, we want to open the floor to questions to make sure that you can kind of like ask anything that, pick your attention. So I'm going to stop sharing and go back here. So we can start the Q&A cuando quiera.
Okay, we have thank you, Vinicio, for your talk. We have a couple of questions here. First, Alberto is asking if you see any kind of expiration date in this boom of the study of the data science field.
That's a great question. I don't see a decline of this in the sense that data-driven decisions are made every day now. So think of everything that you are doing in your everyday life. So you're probably taking the subway with a credit card or maybe with a little bit of car. That's data that is gathered. You have a smart fridge or la nevera inteligente. You have your laptop. You go through Twitter. You go to Facebook. You go to YouTube. You use Netflix. You use all of this. All of these areas are data that is being collected from us. And I think more and more data is being collected from the user. So companies are making decisions more and more using that data. So I don't see a decline. What is going to happen, of course, is that companies are going to understand their necessities better. So this data science will stop being so broad, and they will be kind of like focusing like, hey, you know what, we need just a machine learning engineer, or maybe I just need a data analyst or a data engineer. But I think data science as a whole is here to stay.
So perhaps you think instead of a decline, it would be an increasing of the study of.
I don't think we have reached the peak. We still have time to reach that peak. Yeah.
Okay.
So again, tech companies have they are already mature in data science. Finance, for example, only started building data science model maybe 2 years back. A lot of funds and hedge funds are building their data science teams. Pharma is getting into data science I think 2 or 3 years ago. So again, it's exploded into it. Entertainment. So Disney Plus, NBC, all of these, any channel that you have in US or outside of the US, they're using now data to making decisions to see what's the best programming. So I think it's just here to stay, and it's just starting to explode.
Okay. Well, the next question is also from Alberto, and he's interested about in the institutions you make part of, and how can you match this business knowledge you were talking with the students? How can you do that?
That's an interesting question. So I think depending on where you go working, so a couple of things. A lot of programs that we have, they're focused on learning from real practitioners. So when you build your plan of study, when you build your curriculum, following practitioners, you know that the skills that you're learning are skills that companies are looking for. Okay. So in terms of study plan, like I said, it's very important for learning the business through internships. Okay. So how do you get business knowledge as a student? Well, you need to do internships. You need to learn about those different areas that you want to work on. So for example, you can take internships in tech, you can take internship in finance, you can take internship in pharma. So I think la pasantía, the internship, will be one of the main components. And then it's all about learning about their problems. Something that as a data science you'll see is that problems are universal, meaning that the same problems that a bank has are the same problem that an entertainment company has. It's just different way of expressing it. So if you are a very good storyteller, you're able to change the protagonist very easily and then put your story towards the business that you're working on. So I think it's all about learning about the area that you want to work in the future and try to take an internship to get that exposure.
Okay, perfect. The next question is from Uriel, who is asking, in your opinion, what is the relationship between these new techniques of machine learning and operation research?
Yeah, that's a great question. So operation research o investigación de operaciones, mostly based on logistics. Okay, investigación de operaciones, typically we use, nosotros la usamos para que el problema de transporte, tenemos para el problema de cómo distribuir la logística dentro de una compañía. También tienes el método simplex para hacer lo que nosotros llamamos problemas, donde pones las distintas constraints y después lo resuelves buscando una función objetivo. Todo eso que acabo de describir es machine learning también. Okay? So machine learning is also looking at cost function, which will be your objective function. They have parallels. You still have constraints. The only difference is that in investigación de operaciones, normalmente las restricciones son lineares. And in machine learning, las restricciones pueden ser totalmente no lineares. So puedes aprender más realidad. Okay? Now, another big element of machine learning is graph. So for example, the transport problem, transportation, can be easily solved through graph theory, which is something that you learn from operation research and you can easily translate it into machine learning. So there are a lot of relationship between them. So again, if you know the optimization piece of investigación de operaciones, it's going to be very easy to translate that optimization knowledge into your machine learning processes.
Okay. Well, the next question is from Alberto too, and it's about how can we convince some of our companies who have, well, company has already a traditional process. They do in a particular way that may not be from data driven of capturing data, and how can we convince this enterprise to switch to these processes?
Great question. Uno tiene que ser un evangelizador. Evangelizador de la data, creo que es uno de los más importantes elementos si quieres transformar una compañía. Tienes que tú ser el evangelizador. Yes, that's true. A lot of companies are hard to shift into what they used to do into a more data-driven decision. So you need to look for examples. And in any company, in particular the traditional ones, they're going to be what we call easy pickings, mango bajitos. Some things that you can easily take and just explode and show to your supervisors or show to the executive committee, hey, this is the traditional way, but if we do it in a data-driven way, we get better results, we're faster, we're more precise, and we use better resources. So I think that should be the main approach. Make sure that you can easily evangelize and be a driving force for that. And it's going to happen. A lot of companies where I work, for example, banking, and I work in banking here in the US for almost 4 years. Banking is one of the slowest industries to change. A lot of what I did was optimize their Excel spreadsheet. Again, using Excel at this point but they still use it. But you have to be that driving force that say, hey, let's automatize the process. We're going to learn better about our models. I think we're going to get more data. We're going to make better decisions. Our errors are better. It's easier. We're quicker. I think one of the things about data science is that you can be quicker at making decisions because changes in behaviors are easily picked compared to a traditional method that takes time to gather the historical data.
Okay. And we have a quick question here for Alan, who is asking if it's necessary to hold a PhD degree to be a good data scientist.
Not at all. Not at all. Great question. Not at all. Not at all. I don't have a PhD. I have 3 masters, but yeah, I love studying. But I would say that it's not needed to have a PhD. PhD gives you a lot of research capabilities. So don't get me wrong. If any of you is planning to get a PhD, go for it. That's fine. But it's not necessary. Again, a good data scientist is a good storyteller. So if you have experience in a field, that can easily overcome not having a PhD degree because you know how to tell stories. You know how that industry moves. And that's sometimes even better than just having experience with a PhD. A PhD is only giving you what? The scientific method. And I think you can get the scientific method from other ways. So it's not exactly needed. Now, there are some roles that are research heavy, meaning that, so for example, big companies, they have their production data science, where they get people that are young, that are people that understand the business, that it's all about solving problems. But you also have some research facilities where they are trying to solve more, let's say, bigger problems. And those are more publish-based, where you have to publish a paper. So on those roles, you may need to have a PhD to kind of like fit. But that's one role. That's the research data scientist. There are multiple other data scientists that, in fact, they want people that don't have that much of a PhD and are more business acumen.
Okay. We have another question here from Alan, who is asking also if it is normal for a data scientist to only implement algorithms that we already know in machine learning, or if it is a task, also a task to develop new algorithms.
Great question. I didn't discuss one thing that is called the data science life cycle. So you have your data at one particular point in time. From that data, you build your model. And again, the model can be traditional. It can be known. Again, these models are there for a reason. And even though they're known, like you mentioned, they are still very adaptive to your data. So again, that's why, for example, decision trees are very simple models, but they adapt quite well to a lot of data. Okay, so great. Now, once you go through that, you're going to have a period of testing. Like, hey, I'm going to be doing this model. I'm going to be using this model for 6 months, for a year. And then after a year, you're going to get new data. So now the process starts again, but quicker. Like, hey, let's see if the current model is still behaving the way that we want, or we have a better model with the new data. So there's always this life cycle. You can develop new algorithms, but typically when we say develop new algorithms, is something that we call ensemble methods, which is using known algorithms, but in different combinations. Those are quite effective. So like I said, yeah, you typically are going to be using known algorithms or a combination of those. And yeah, you can always develop new things that you feel comfortable with, but it's not needed. I think it's more data. The data will dictate what you need in terms of the algorithm, not the other way around.
Okay. We have another question from Sarah. It's a very general question, I think, so I'm going to narrow it a little bit. I would ask you, what is the main thing you will look for in a data scientist? If you had to pick one main thing, what would that be?
Yeah, so what they're looking for a data scientist is storytelling. Again, it sounds kind of like counterintuitive, like
yes,
what? But it's very interesting. Whenever you go to a job interview as a data scientist, and I have gone through a few, the real differentiation factor is how good are you at telling the story. Meaning, you have the data, you have to be a master in coding, well, not coding, but at least understanding how to work with the data. So again, that can be taken with experience in Python and other languages. But after that is, okay, what is the problem? So you start by asking the right question. Then, what is the data telling me about the problem? And then, what is the insight of the data applied to the model that I'm creating? And you can build then a story. Like, this happens, then this happens, then this happens, and then this happens. If you're able to tell a story, you're able to convince your other data scientists, you're able to convince the executive committee, you're able to convince anyone. And that's what they're really looking for in data in the industry. It's a data scientist that is not just a code geek. It's someone that can easily go to the executives and say, hey, according to the data, we need to do this. And then you tell the story based on that. So storytelling is a very important element of good data science.
Okay, it's quite interesting, in fact. Well, the last question we have here is from Joanna, who is more driven to the operations research, and she's asking, what techniques are the most used, in your opinion, right, for optimization problems in...
Great question. So like I said, in IO, investigación de operaciones, a lot of the initial elements is linear models. No, so you probably have learn about simplex and you learn how to use all of these linear methods, where at the end you have your sensitivity analysis. All of that is fine. However, in data science, in optimization, we typically have more non-linear problems. So it's very simple, where you still have to have a objective function, you still have your constraints, but then you're probably going to do what we call gradient descent to solve the problem. So gradient descent is, I would say, the most important optimization technique that you need to learn. And gradient descent is based on the Newton method. So if you know the Newton method to find zeros of an equation, gradient descent is based on that. So it's based on your loss function, then where you need to point, and then you start building an iterative process to find the optimal value. And another thing that I will highly suggest is learning convex optimization. A lot of machine learning algorithms are based on convex functions. So learning convex optimization will be the most important area of investigación de operaciones.
Okay, well, I think that's enough for the questions. We have no more ones. And well, thank you again, Vinicio, for your interesting talk about this this field. We are very grateful for it, for you took the time for being here with us. And well, now I'm going to let Luis display a certificate of gratitude in the name of our institution. Please, Luis, go ahead.
Universidad Autónoma de Nuevo León, through the Facultad de Ingeniería Mecánica y Eléctrica, present this certificate to Vinicio De Sola for his participation as a speaker of the talk Introduction of Data Science in the first 2022 cycle of conference 2022 of the postgrade in System Engineering, Alere Flama Veritatis, May 6 to the present year. Muchas gracias por venir, Vinicio, y eres bienvenido siempre que quieras con los brazos abiertos.
Muchísimas gracias. Disfruté bastante de esta presentación. Muchísimas gracias.